So what I've got going here is based on CNB's hidden door. This is one of CNB's maps. There's some flip-flops and whatnot laying around here. What I did though was I designed this so that there's a safety mechanism, or a lockout I guess you could say. Works like a standard door. You press the button, uses a flip-flop to activate. But the secret sauce is right over here. There is down inside this hole there's a block on which you place a torch. If that torch is not there, the door does not work, so you're going nowhere. Place the torch. And you're back in. So if we take the torch off here and we go inside, we got a button inside too. That button always works. So we can just imagine this is like the gateway to your secret lair or something like that. This allows you to get in, and then no one else can get in behind you. So if we kind of cheat here, go back around front, you can see the door's closed and no one can get in because I took the torch with me. Now this is a little bit obvious over here, so I usually would cover it up. I leave it sandstone in sand. This is just kind of camouflage out here. There's no redstone wiring inside this or anything. It's just to illustrate, I try to hide my hidden doors even though they're flush with the wall. I try to hide them behind stuff so that they don't look so obvious. And I'll stick the button on stone. This is sand map, so it's a little harder to conceal it. There's not a lot of stone laying on the surface, but in other biomes it's pretty easy because there's usually some stone on the surface that you can stick a button on, and casual observers, when they're walking by, they don't notice the button quite so easily. So over here I have a cutaway version. Kind of show you what's going on here. This is the button on the front of that sand pile. Over there is my secret torch in the doorway. It's right in front of us. So this is just CNB's standard 2x2 hidden door. I've built it per his specifications, no special adjustments there. This is all his design, not meaning to take any credit for any of that. This is just for those of you out there who are new to Redstone and have not really combined many circuits yet. So you might have watched CNB's tutorial and seen all these monostable circuits and flip-flops and things that you don't understand. This is a really simplistic example of how you can combine these to do some cool stuff. So the way I limit the door, or lock the door I guess you could say, knock that torch off. So this button no longer works, and the way that operates is using something called an AND gate, A-N-D gate. So that's it right there on the ground. I've got one set up over here that we can look at outside the constructs. So we got an AND gate here. We got a couple of blocks with some redstone connecting a very basic circuit. So I'm going to power one of these and we're going to look at what happens. So I flip the lever, that powers the blue block, which lights up this redstone. This redstone powers this block, and because that torch is on top of a powered block now, it turns off. Now there's a piece of redstone in between, so that torch is still lit, which is powering this redstone. Redstone powers the block that it is in, so there's like a phantom block there that the redstone exists inside. You can't build inside it. And it also powers the block that it is on top of. So the block underneath the redstone is powered, and then this torch is attached to that powered block. So we still don't have any current being generated here by this redstone torch. If we come around here and we flip on the other switch, you can see the other side, or sorry, lever. The other side is powered now, and this torch goes off. Because these two are connected, there's nothing left to power this redstone. The block underneath it is no longer powered, and this redstone torch turns on. That powers this redstone here, and we can see the the piston go up. So if we flip this switch, either or, we can kind of see that both of them have to be on in order for this to work. Otherwise, we got a no-go. That's one part at play here. So what I did was I wired in the AND gate to 2 circuits. You can see this this redstone wire here is going to feed in from the torch. So I'm going to put the torch back and we should see that light up. Yeah. So that lights up one side of the AND gate. Now over there, the power was coming in from the back side. That's not a necessity. You can't power it from the front unless you use repeaters, because you'll get crosstalk between redstone wire here and all this stuff over here. So I just came in from the side, nice and easy. It powers that block, turns that torch off. That one's still lit though. We will turn that one off by powering this block, which sends redstone down and temporarily activates that torch there. We can kind of see it. Off and then on. And then the output of the AND circuit is fed into this whole wiring back here that we'll get to in a second. A quick note on this circuit here and this stuff over here. So the redstone torch attaches to this special kind of stone block that I dropped in there. That torch powers this block. That block transmits to a repeater. I used a repeater because if I use redstone, it's going to power the block that the torch is attached to, turning it off. It'll get caught in a little feedback loop and eventually it'll burn itself out. So redstone repeaters are useful because they don't, they only feed power. They take power from this end, and the only place it's going to come out is the direction that little pointer is pointing. So I go over one using a repeater into another repeater that goes to a block. That block powers the redstone below it. That redstone powers this block powers the repeater powers this block, which powers the redstone below it, which powers over here and into the AND gate. So this little guy here is just kind of the same principle. Redstone can be powered by the block above it, so when I hit this, that redstone lights up and the whole circuit gets activated. So let's kind of look a little further past the AND gate. So the AND gate requires power from that circuit and from this circuit. So easy enough. If we power both of them, we get output on the other side. What are we going to do with the output? This goes somewhere else. You can just ignore that for the moment because we don't. It's completely irrelevant. It doesn't have to be there. Just gonna give myself some redstone real quick here. I'm just going to knock it out so you can see that the thing works without that in place. So you can see the door still operates. The output of the AND circuit, or the AND gate, is fed to this little flip-flop right here. And that's another one of CNB's designs. A very handy little piece of equipment called a compact T flip-flop. Press the button, some action occurs, and on the other side we see this piston is activated. So what's happening here? These T flip-flops take advantage of some peculiar behavior of pistons. So if you have 2 pistons facing each other and both of them are powered, one is going to be out and the other is going to be in. And if you remove power and reapply it, oops. Not what I meant to do. If you remove power and then reapply it, they swap. So this one's no longer out and this one is. So they go back and forth. Easy peasy, right? So what's happening here? When I hit the button, it powers this block. That block lights up the redstone and transmits power to the block next to it. So the reason for the redstone is to make sure that both of these blocks get powered when you feed input to this block right here. So I'm going to hit the button. You can see the torches turn off because all of a sudden these blocks are powered. These torches are what is powering the pistons. So we cycle the pistons off and then on again. Now that back and forth movement moves this block here over a torch that is in a hole in the ground. So when this block moves over the torch, it becomes powered. Block's now powered. There's redstone on the other side. That transmits to this block and up goes the piston. So going back to our example, we can see the output from the AND gate is sent to the input of the flip-flop. So it just comes in here and runs into this block. So as soon as you power it, if I just stick a torch next to it, you can see those blocks get powered and the torches turn on. The pistons are now unpowered. Take the torch away and the pistons power up again and they cycle, and the little block down there's moving back and forth. Now I have it backwards. The torch is on this side, but that's under that side is just a block, so there's no power. So you can think of a T flip-flop kind of like a lever that you turn on and off by applying power and then taking it away. So if I power it and I take power away, you can see it cycles. So now the block is in place and power is being transmitted back here. Back here is, this is just CNB's door design. I'd recommend you watch his 2x2 compact door design tutorial. It's really, really good. It's a simple design. That little channel just feeds power to these redstone torches, which generate the movement of the door. The last little bit that we've got going on here. So I wanted the door to operate all the time from the inside. So once you're inside here, it's really important to be able to get out. So you need this button here to function all the time. So no matter what, I want this to work. I do that with a little down direction redstone circuit that feeds the signal underneath. I had to go down here to avoid powering some other stuff. So this just comes across and feeds into the circuit that cycles the flip-flop. This circuit joins here in front of the AND gate, but it doesn't trigger the AND gate because this is the output of the AND gate, and AND gates are one way. So really all this is just an additional power conduit to the flip-flop. You'll notice when you hit the button here, it lights up that whole redstone circuit down there, but it doesn't matter because it's just a button. It's going back to the other side, and it goes nowhere because that down circuit doesn't transmit power in the other direction. So kind of the only other thing I wanted to show you that's useful when you're building this kind of stuff is how to get power downward in a compact space. It's really useful. You can see here that sending the power down gets it underneath all of the other circuitry I've got underneath there, so that we can get it across to our flip-flop without running into a bunch of stuff. I do that with a compact downward transmitting redstone circuit. You can see right now it's not lit up. I'm going to hit the lever, powers up, and we see the piston go up. Same concept as my redstone torch lockout mechanism and the button on the back side. When you apply a lever here, this block becomes powered, transmits power to the repeater, which does not transmit power underneath it. It powers this block, which in turn powers the redstone below it. The redstone below it powers this block, repeater, block, redstone, power block, repeater, power block, redstone, and there's your output. So you can take output from this at a few different places. If you wanted to, you could take output here, so you can take it on the bottom. You can take it here. You cannot take it here. So you're kind of limited. There's like a minimum amount you can go down with this design. But here's, you can take it out at 1 block down, and then a little further down at 4 or 5 blocks down. So limited utility in some intervening layers, but overall it's the most compact method for getting redstone downward in the game. Hope that helped some of you out a little bit. I know the tutorial was a little bit long, but I went into in-depth explanation for most of the components. So if you have questions, leave them in the comments and I'll see what I can do to get to them.